Here we are with section 3.3, measures of variation. We've got one extremely important idea in this section that we'll get to in just a minute. But first, let's take a look at this example. There's these two students that took 3 quizzes. The quizzes were 10 points apiece, and take a look at the results. We've got Jack and Jill. Well, Jill is actually a very good student, but there was this incident with tumbling down a hill, some breaking of the crown, but she's all right now. But she unfortunately did not perform well in the first quiz. She got a 0. She improved, and finally by the last quiz she was back to herself with 100%. Jack, on the other hand, isn't doing too well in the class. Luckily, Jill's been helping him out, so he has been improving, but just by 1 point each time. Well, let's review some of the things that we've just learned recently. Find the mean, median, mode, and mid-range. All right, the mean. Add 3 scores, divide them by 3. When you do that, you'll find that each of them has a mean of 5. The median. So you put them in order, and whatever score is in the middle, which for both of them is this 5. So the median, 5 for each of them. The mode is the score that shows up the most. Well, there is no score that shows up the most, so no mode for either one of them. And finally, the mid-range. Just take the average of the biggest score and the smallest score. So for Jill, that's the 10 and the 0. For Jack, it's the 4 and the 6. And again, you get the same number, 5. So as far as those things, there seems to be no difference. But if you look at it, you can see that Jack's scores are more consistent. His scores are only 1 point apiece, 1 point apart apiece, while Jill's are 5 points apart. So how do we measure consistency? Well, there's 3 ways we're going to do it. One is extremely easy. Second one is extremely important. This is the easy one, range. You just take the biggest score minus the smallest score. It doesn't really tell you a whole lot of information because it skips all the scores that are in the middle. Here's one that we're going to use for the rest of the semester. This is very important, standard deviation. So what you do is you take each score, so this one does include every score, subtract from the mean to find out how far away from average is it, then square, which actually gets rid of negatives, add those up and divide by n minus 1. At the end, you take the square root. In a way, now this isn't exactly true, but it's approximately true. The square and the square root sort of cancel each other out, but by squaring you get rid of negatives. So this will never be negative. Standard deviation will never be negative. The third one that's covered in this section is called variance. And to be honest, we're not going to use variance until about chapter 7 or 8, but the good thing is it's easy. Once you have standard deviation, the variance, all you have to do is square it. So now let's do those 3 measures with Jack's scores, 4, 5, and 6. Like I say, the range, easy enough. You just subtract. He's got a range of 2. Now we're going to find the standard deviation. So you start with a mean of 5. Then the formula says take each of his scores, 4, 5, and 6, subtract the mean, and square it. So this would be a negative 1 squared, so that's 1. This is 0, and this would be 1 squared. So there's a grand total of 2 on the top and 2 on the bottom. That turns out to be a 1. Next, the variance. Like I say, just take the standard deviation and square it. In this case, 1 squared is still 1. Now with Jill's scores, a 0, a 5, and a 10. So here we go with the range, top minus bottom, 10. And then for the standard deviation for Jill's scores. So you take each score, 0, 5, and 10, subtract, and then square it. Subtract and square it. So this is going to end up to be 25, and 25 is 50, but divided by 2. So that's square root of 25, which is 5. So there's the standard deviation. So as you can see by these little check marks, finally we found something that can tell the difference between them. Jack's scores are very close and compact, 4, 5, and 6. Standard deviation is very small, a 1. Jill's scores are off by, or they grow by, 5 points each time. Standard deviation, larger. Finally, the variance, 5 squared is 25. All right, so we could see that the Jack's standard deviation was smaller because his scores have less variation. Like And also the opposite, if the standard deviation is bigger, that means there's more variation. So basically, standard deviation is a measure of how much the scores vary around the mean. Are they all very close to the mean, or are they spread out? So here's one example. If all of the scores were the same, what would the standard deviation be? You're right, it's 0. Because if all the scores are the same, there is no variation, so S would equal 0. Here's another example, just a few numbers. Take a look. Which one do you think is going to have bigger standard deviation, set A or set B? Well, set A, these numbers only go up by 1 each time. These go by 4, and then 3, 2, 5. There's a lot more variation here. And in fact, if you find the standard deviation, it's true that for B, bigger standard deviation, more variation. Okay, so then which do you think would have more variation, the heights of teenagers or adults? Did you pick teenagers? It's going to be the teenagers. So the heights of adults, so for one thing with this question, it is, let's say that at one point in time, today, right now, everybody was measured. So it's not over time. Some people have thought about this question and said, well, over time, the teenagers are going to grow and grow while the adults don't grow. No, this is a snapshot in time, measure everybody. So the teenagers, well, since they are the children of adults, whatever variation there is in the adults, genetically, there's some people, adults that are tall and some adults that are short. Well, they are going to produce offspring that are also either tall or short. So whatever variation there is in the heights of the adult population, that's going to be passed on to the teenagers. The teenagers have more variation on top of that because you could have a 13-year-old who has not or has just barely started puberty and is 4 foot something. But then there would be a 19-year-old that could be 6'5". So the teenagers would have more variation. Okay, some notation. The X bar means the sample mean. So that means, excuse me, that means you have a group of 35 people, you find out the average, that's what X bar is. And S is the sample standard deviation. If you're talking about the whole population, so if this was the whole United States, let's say, then we would use the mu, here's the mu, for population mean, and standard deviation would be the sigma. Now the empirical rule, so this is one way that we use standard deviation. So a normal distribution is a bell-shaped curve, and if you take the mean and add 1 standard deviation, take the mean and subtract 1 standard deviation. That's what this means, within 1 standard deviation. So in the bell-shaped curve, the mean would be in the middle, 68% is within 1 standard deviation. If you go out 2 standard deviations, in other words, add and subtract 2 standard deviations from the mean. Hey, for those of you that are visual learners, which I am, I've got a slide right after this with a picture of what we're talking about, but for the moment, we'll just do this in words. So 95% are within 2 standard deviations, and 99.7 or almost all are within 3 standard deviations. So here's the picture of what I was talking about. In the middle is the mean. If you go out 1 standard deviation, so you add 1 standard deviation this way, you subtract 1 standard deviation, then about 68% or 68.26% are within this. And if you add 2 standard deviations and go to the right, subtract 2 standard deviations and go to the left, then in between this red line and this red line is going to be about 95% of the data. Pausing right there, well, that means that if there's 95% between these 2 red lines for 2 standard deviations, how much is left for this tail? Well, if there's 95% in the middle, that leaves 5%. So that's going to be 2.5%, more accurately 2.28% and 2.28%. So very little chance to be over here or be over here. So here's an example. the heights of men. So this would be the mu equals 69.5 and the sigma equals 2.8. So what are the cutoffs for 95% of the men? So you just take the mean minus 2 standard deviations and the mean plus 2 standard deviations, and these two heights in inches are the cutoffs for 95% of men in the United States. All right, that's it. Look forward to seeing you next time. Hey, thanks for sticking around after the first part of the show. What I want to show you next is how to use the old graphing calculator in order to find standard deviation. Well, that formula with the square root and the x minus the what you call and all that squared is beautiful, and it's fun to do once or twice. For the rest of the semester, use the calculator. So watch this. To find the mean, standard deviation, and actually a few other things. So the first thing to do is enter the data. So go right here to Stat, and then Edit. So just hit Enter or number 1. And I happen to have some numbers left over from some other projects, so I'm going to clear those out. So what you do to clear numbers out is go to the top of the list and use this button right here, Clear. Then when you move down, it's cleared out. If you accidentally go up there and think, was I supposed to use delete? Let me try delete. If you do that, then it actually throws the list in the trash, and like this, I accidentally, whoops, just threw away all my lists. Well, if that accidentally ever happens to you, go back to Stat, and number 5 will reset it. And forget it. So, now when I go back, the lists are going to be there. So now I'm going to enter the data. So one person was Jack, had a 4, a 5, and a 6. And then I'm going to use the other list for Jill, 0, 5, and 10. Then go back to the Stat key, and this time move over to Calculate. And we're using the very first one variable statistics. So either hit Enter or the number 1. Now, depending on your operating system, this right here has a little bit newer operating system, you put the name of the list. Otherwise, what it does is just says one variable statistics. It just has this on the screen, and you would just hit Enter. So in here, I have a choice of what list. Frequency, just leave that blank all the time, and then go to Calculate. So we found out that the average is 5. The other important thing is the standard deviation, S is 1. The sample size, N is 3. And in some sections that are coming up, you'll also need these numbers. In order to make a box plot, use these numbers. The minimum, the first quartile, the median, etc. Okay, now how do we find the standard deviation for the other list? So go back to Stat, one variable statistics. Like I say, if you've got a calculator, and the outside of the calculator can look exactly like mine, but the operating system might be different. If you do have an older operating system, it's going to put this word on the screen, one variable statistics, which actually is more than one words. So when it does that, then you're just going to push second 2. Watch. So I've got this operating system, so right now I need to tell it use list 2. Well, if you look right here is L2, but it's in blue, so I have to put second 2. And then it's going to calculate the statistics for list 2. So there we have it. The mean is 5, and the S is 5. We pretty much never use this standard deviation from the calculator because this means the whole population, and it's very, very rare that you would actually type in all the whole population scores into your calculator. But we'll be using this S a lot.